Good afternoon, dear students. How are you all? Be safe at home. Today I brought in front of you all the most interesting topic of the industrial chemistry in your syllabus unit 5, that is green chemistry. In this lecture, we are going to learn the green chemistry concept with its definition and the various principles of the green chemistry in the detailed form so that we should go for understanding the green chemistry phenomena. What is the learning outcome of this unit or the concept green chemistry? The students are able to understand about this concept green chemistry when it was started in the use and the various principles involved in the green chemistry. So let's start. What do you understand by green chemistry? It is the use of the chemistry for the pollution prevention, as the word green means environment friendly. So for reducing the pollution, we should use our chemistry in such a way. It should be environment friendly. How you can use? It can be by means of the proper design of the chemical products and the processes which can reduce or eliminate the use of and generation of hazardous substances. Hazardous substances which are toxic substances. So we should go for reducing the formation of such toxic substances, or we can eliminate such kind of substances if we go in the reactions, and we should prefer those reactions which we can reduce such substances. So that is the green chemistry. We can also understand the green chemistry, or we can define it: design of the harmless processes to produce various hazard-free products has emerged as a new branch commonly known as green chemistry. The concept arose in the early 1990s and was firstly started in use in 1991. So by understanding the concept of the green chemistry, as it is the design or the process to reduce or eliminate the toxic substances, hazardous substances, which should be environment friendly, there are certain principles of the green chemistry to acquire such kind of designing. The principles of the green chemistry was developed by Anastas and Warner scientists. There are total 12 principles of the green chemistry. We should go for one by one each one of the principle in the detailed form. The first principle is prevention of the waste. The waste is always generated in the reaction in the form of gases or the solid products. So the waste should be minimized. The first principle of the green chemistry is. The second principle is maximize the atom economy. Means whatever the proportion of the reactants we are taking, that much it should be taken so that we can have the more yield of the products. The third principle is less hazardous chemical synthesis. Such kind of chemical synthesis should be preferred which having the less hazardous products. So we should go for preferring those chemical synthesis or those reactions which produces less hazardous substances. The fourth principle is design safer chemicals. We should go for the product chemical we are designing that is also should be environment friendly. Design for the energy efficiency. What is energy efficiency? It means the minimum energy requirement should be there in the reaction. That is the energy efficiency. The next principle is safer solvent auxiliaries. The solvents which we are using in the reaction or some separating agents we are using in the reaction, that should also be environment friendly. The use of renewable feedstock, whatever the raw materials we have selected for the synthesis of the product, that should be renewable, means that can be recycled, that can be reused again. The next principle is that to reduce derivatives. For example, if we have a reaction having the reactant A, this is A reactant, which combines with B to produce C. First, it is converted into C, and then it is converted into D. So here we have a reactant A which is combining with the reactant B to first produce C, which is an intermediate or a derivative we can say, and it is converted, finally it is converted into D, and we want D by this reaction. So what happened? This should be minimized. The C formation should be minimized. So unnecessary the C is producing. So we do not want C. So it's such kind of the green synthesis should be accepted when we should go for producing D directly. So that's the principle, reduce derivative. The next principle is use of the catalyst. The catalyst, you all know, it enhances the rate of the reaction. So using the catalyst in the reaction, faster the reaction takes place, and it minimizes. Again, if we go for using the catalyst, we minimize such kind of intermediates like the C formation. So we can go for minimizing such kind of intermediates or the derivatives. Then the next principle is designing for degradation. Degradation means it should be environment friendly, biodegradable nature. So such kind of designing should me prefer that the degradation can be easily occurred. The next principle is real-time analysis for pollution prevention. We should go for such kind of analysis so that the pollution can be prevented, and the safer chemistry should be there for the accident prevention. So that can also be, means it should be very safer reaction. It should not acquiring any fire or such kind of accidents, producing poisonous gases and all. So that's the principle, safer chemistry for the accident prevention. Now one by one we have to go for. The first is the prevention of the waste principle. The hundreds of the tons of the hazardous waste are always released in the air, water and land by the industry every day and every hour. So it goes for producing hundreds of the tons. If we are talking about it, the large scale production. So a large scale hazardous waste can be released in the air or water or land, causing the pollution. It is better to prevent the waste than to treat over clean up waste after it has been created. It is better to prevent or to minimize the waste rather than we are just releasing it and just thinking that it is cleaned up. So that should not be adopted for the green chemistry. If we are talking about the green chemistry, mean it should be minimized. It should be prevent the waste. It should not be clean up and just throw it up in the environment. So that is not the safer rule. So for the green chemistry, it should be minimized. It is the ability of a chemist, means it is the chemist should have the responsibility to redesign the chemical transformation, to should go for redesigning. Understood? Redesigning, it should be go for transformation to minimize the generation of hazardous waste. That should be. If such kind of the process is adopting or in the industry, so it's then responsibility to redesign the process. The chemical process should be designed in such a way that less or no byproducts are formed. It can be gas like HCl or H2O water. It is forming in a large amount. That should not be required. So that is the first principle, prevention of waste. The next is design of safer chemicals and products. So the chemical product which we want to design, the chemical product, either the chemicals or any other product we are designing, so it should be of high efficiency. It should be of high efficiency and low toxicity. So whatever the product we are going to design, it should be of high efficiency and low toxicity. For example, a medical drug to be introduced in the market, first put on trial. Okay. So when we go for the synthesis of any drug, it should go for trials to check out its toxic effect. So it should be checked out on the animals, and then whatever the effect should be seen. If the effect is toxic, we have to go for alternatives. If it is found toxic, the alternative should be prepared. And so that only toxicity to be removed, such kind of alternative we should prefer. So for that, toxicity is removed, not the efficiency. So that is the designing of the safer chemicals and the products. We should prefer those products or the chemicals having high efficiency and low toxicity. And like if we are synthesizing any, it should be tried first to check its toxic effect. If it is producing this effect, we should go for minimizing its toxicity. But we should not go for changing its efficiency if it is high. The next principle is use of the safer solvents and auxiliaries. So what is an auxiliary? It is a supporting agent. We can say the agents or separating agents. It should be avoided wherever possible. The solvents like acetone, benzene, ether, these are highly inflammable solvents which cannot be used. The carbon tetrachloride, chloroform, aniline is also very harmful for health, carcinogenic in nature. It should be avoided. If the solvent is required or the necessary, we should use such kind. The water is very good medium to be used as a solvent wherever we want, that is eco-friendly solvent. which do not form any smoke or destroy the ozone layer, which is forming the harmful gases. For example, in a dry cleaning fabric, a toxic solvent is used, that is perchloroethylene, which is replaced by liquid CO2 in the recent years. So using the toxic solvents or any other kind of agent in the reaction which is harmful, which is not eco-friendly, it should be avoided. The next principle is energy efficiency. It should be increased. Energy efficiency should be increased. Energy requirement of the chemical process should be minimized. Understood? Energy, whatever the energy is requiring it should be minimized. The reaction should be carried out the ambient temperature, means at the normal temperature. We can say at the room temperature or the ambient temperature. The reaction should be performed at that, or pressure also. The normal pressure, normal conditions if we are going through. So wherever we want to have such kind of synthesis, it should be sufficient. And the use of catalyst is also, we can carry it out so that the energy is minimizes and we can stop the excessive use of fossil fuels. And we can go for substitute of energy use, like if we want energy to use in the reaction, the microwave radiation are the substitute energy, or ultrasound. These can be used as an energy substitute which is require less energy. So that can also be done. The next is fermentation. If we go for fermentation process, it also require the lesser energy. It is an alternative. So energy efficiency, better energy efficiency we want for the proper heat transfer and the minimum wastage of the energy during the process. So energy efficiency should be proper, and properly it go for heat transferring and minimum wastage of energy occur. The next principle is avoid chemical derivatives. Avoid chemical derivatives during the synthesis, as I have explained earlier. Derivatization such as blocking or protecting group. Blocking or protecting group should be avoided. It increases the step of the process, because as I have go for A plus B to C to D, means C should be minimizes. When we go for increasing more step, the addition of the reagent require to generate more waste. If we are producing C which do not require, it produces the waste. The next principle is use of a catalyst. A selective catalyst or the reagent should be preferred in the stoichiometric reagents. It should minimize the waste, as well as if we go for using the catalyst. Catalyst is always uses in the small amount. And if we go for using a catalyst, it can be reused and it can be used for many type of the reactions, or the same reaction it can be used many times. So this is the benefit of using the catalyst. And if we go for performing, you not using the catalyst, only reagent we have taken, so that can only be used once. And if we are using the catalyst, the reaction is faster and they require the less energy, which is advantageous. The next principle is design chemical and product to degrade. Means it should be degraded. It should be designed that it should not be break down in the non-hazardous substances after use. For example, we know about DDT. DDT is used as a pesticide and now it is banned. But when it was used as a pesticide, its residues remain in the soil, which carries out the pollution, or we can say it causes a severe effect on our food chain. The alternative is used, we can go for using a biological insecticide. The same as plastic is also non-degradable and cause the solid waste. The alternative biodegradable plastic is which is containing the cellulose, and the packing pellets which is made up of starch can be used. The next principle is the real-time analysis or for the pollution prevention. So we can go for the such kind of the analytical method which can allow the online monitoring. For example, the preparation of ethylene glycol, if the reaction condition are not monitored, if we are not monitoring its reaction condition perfectly, the toxic substances are produced at the high temperature. So such kind of analysis should be there, or it should be monitored like that reaction, so that it should be minimized. The toxic substance which are produced, it should be minimized. The next principle is safer chemistry for the accident prevention. The substances and its form used in the chemical process should be chosen to minimize the potential for the chemical release. It should prevent the accident like explosion, fire. Such kind of substances should not be released, or chemical should not be released which highly inflammable or catches the fire and produces the accidents. User of the safer chemicals, minimizing the temperature, pressure, using catalyst. If we are doing all these step by step, we are minimizing the energy or the temperature or pressure using the catalyst, it should help in minimizing the potential of the accidents. The next principle is less hazardous chemical synthesis. The synthesis method we are going to design in such a way the substance have a little or a no toxicity to the human health and the environment. So we should go for such kind of the synthesis which is produce less or no toxic products. So, a less hazardous chemical synthesis should be adopted if we have such kind of the raw materials, we are starting materials, we are preparing like aniline is there or pyridine is there, which are very carcinogenic. It should not be used as a starting material or any kind of product we are getting. The reaction in which intermediate or the reagent or product are toxic, we should not go. As you have the example in 1984, the leakage of a severe gas MIC, methyl isocyanate, in the production of the agriculture pesticide. So when we are going for producing the agriculture pesticide, a very harmful methyl isocyanate is released, which is highly poisonous and which is responsible for the Bhopal gas tragedy. It is very serious. We should not go for such kind of reactions. It should be have the other alternative. So such kind of reaction should not be accepted in the green chemistry. Likewise, the another example is synthesis of the indigo. If we see, which is a dye. Indigo is what? It is a dye to color the blue jeans. If we go for having the blue jeans, it is of indigo, the color. So if we talk about its preparation, its raw material is aniline. The conventional route of preparing such kind of dye is aniline, which is very harmful. So we should go for the greener route. for the synthesis of the indigo, and it can be done using a raw material tryptophan. So we should go for another route, that is the greener route, which is more good, environment friendly, as we are using in the previous traditional route aniline, which is very carcinogenic, which is harmful to our health. So that's why we should prefer this kind of synthesis, producing the less hazardous substances. The next principle is atom economy. It is defined as the ratio of the formula weight of the desired product to the sum of the formula weight of all the reactant. We can find out. So such kind of ratio is mostly preferred to, we have such kind of reactions to maximize the materials we have used as a reactant to achieve our final product. So that is should be our aim of the atom economy. So by finding out the weight of the reactant we are taking and the weight of the product we are getting, the ratio to be seen likewise, so that the maximum final product we are getting. So that is atom economy principle. The last principle of the green chemistry is use of the renewable feedstock. What is feedstock? The raw material we are using in the reaction, it is called the feedstock. It should be renewable, means it should be reused rather than repeating or depleting whenever technically and economically practicable. So these all are the 12 principles. If we go for following these 12 principles, so that we can achieve our designing process such that which should be green, environment friendly, and reduce our hazardous substances. Thank you and take care.